This video is on titrations and titration curves when you have a strong acid and a strong base. So a titration is when you have a solution containing a known concentration of an acid is added slowly to a base, or vice versa. And this is done through the use of a burette. So please excuse my terrible drawing, but a burette is that tall, skinny piece you probably haven't seen since we did our equipment test. It's got a little knob right here for you to turn to let the solution out or stop it. All right, and you hold this on a clamp, and then down below here would be your the base of your ring stand. Okay, so below this would be some sort of flask. Typically, it'll be like an Erlenmeyer flask, and in one of these, let's say this. And one would be a known concentration. That would be in your burette. Known concentration. And then in your flask would be your unknown concentration. And what you can do is you can add your known to your unknown, and we'll use an indicator to change color at a certain pH. And here you can look for what's called the equivalence point. So let's go back up to the notes here. So this curve is where we can tell our equivalence point, which is how we can calculate our unknown concentration of the acid or base, whichever one it is. So you do a plot of your pH versus the volume during a titration. That's what the curve is. So we use an acid-base indicator to signal the equivalence point. It'll just change color at a certain pH. And curves typically have very characteristic shapes, which you'll see in a second. So let's look at kind of the different steps you'll have, the different kind of points on a titration curve. So consider A, for our example, consider a strong base. Let's use like NaOH, for example, added to a strong acid. We use HCl, for example. So that means in our burette is our base, so our NaOH in this case, and in our flask will be our acid, or our HCl, plus our indicator. Okay. So we can divide the titration curve into 4 parts. So the initial pH, so before we add any base, okay, so all our base is in our burette and our acid is in our flask here, okay? So the initial pH of that is just the acid. So if it's only acid, we know that our pH is going to be less than 7, okay? So that's our starting part of our curve. So if I go down here, and you have this in your notes packet, that would be right here. That would be this point. This would be our initial point. This would be part 1, right? Below 7, right? Here's our 7, because we have an acid. All right. So then, between the initial pH and the equivalence point, is our second part. So this is after we've added base, but we're not at the equivalence point yet. So at this point, we've added some base, but we still have more acid than base. So the strong acid is in excess. So we have more acid. If we have more acid, that's in excess, our pH is still going to be less than 7. However, it's going to be higher than the start. Okay, so if I go down to the graph, that's going to be, and I'll do that in a different color, that's going to be this whole part. This is going to be part 2, okay? We're still, actually, it's even going to go all the way up to here. It's still going to be below 7, all right, but we're not at the equivalence point yet. All right, so 3 then would be the equivalence point. And this is when we have the amount of base equal to the amount of acid. But now this is a stoichiometric equivalent. So if we have NaOH and HCl like in this example, there's 1 mole of NaOH for every 1 mole of HCl. And that's because NaOH plus HCl would give us water and NaCl. So in our balanced equation, it's a 1-to-1 ratio. And that's a 1-to-1 ratio of OH minus to H plus. All right, so we'll have equal amounts of acid and base. And when that happens, we have a pH of, I hope you know, 7. So that would be right, we'll do this in blue, right here. So this is our equivalence point. This is 3. All right, so then the last part would be after the equivalence point. Okay, and the pH is now determined by way of excess base. So we keep adding base, okay, and now we have more base than acid, so now our pH will be higher than 7. So that would be up here. This is part 4. All right, so this is a sample curve. So you can see as you're adding base, right, you start here, you're acidic. As you add base, you get less acidic. And then you're going to get to this point where all of a sudden right here, you have equal amounts of acid and base, right? Right here, you have pH of 7. And then as you keep adding base, it's going to become more and more basic. Now, in the reverse, all right, oh, and by the way this is written strong acid, strong base, this is our flask, this first one, and this is our burette. So what if we reverse them? What if your flask is your base and you're adding acid? Okay, look how the curve differs. You start very basic, right? You have a strong base, you haven't added any acid yet. So here's where our pH is. And as you add more acid, it gets less and less basic. So you get to your equivalence point, right here. And then it's going to get more and more acidic and level off as you add more acid. So those are curves for a strong acid and a strong base.